Hi, everybody. We said earlier that a function written in the form y equals mx plus b is said to be in slope-intercept form. And that was sort of a mystery. Why is it called slope-intercept form? I answered half of that mystery in the last video. The intercept part comes from the fact that this b here tells us where the y-intercept is. As long as we put a 0 in front of it for the x value, then 0b is exactly where the y-intercept would be. And now I'm going to answer the second half of that mystery, which is that this m over here tells us exactly what the slope of that function is. And remember that slope is really the rise over the run. When we say the slope, that means that it's what you get if you take any two solutions on the graph and measure the vertical distance between them, that's the rise, and the horizontal distance between them, that's the run, and you divide the rise by the run. By definition, that's what the slope is. Okay, and slope tells us just how steep something is. So let's look at an example over here. We have the equation y equals 3x minus 2, and here are all these solutions plotted out on this coordinate plane over here. For example, one solution, which I call solution 1, is just the point 1, 1. Okay, and that is right over here. And you can verify for yourself that if you plug 1 in for x and 1 in for y, then both sides would end up being exactly the same. And another solution is what I call solution number 2 over here. Remember, there would be an infinite number of solutions. I just have 2 written here. 2, 4, that would be another solution. And again, I'm not going to do it, but you can check for yourself. If you plug 2 in for x and you plug 4 in for y, and then you just evaluate this side, you'll see that both sides turn out to be exactly the same. Okay, now just a little bit of a review of the last video that you watched. The rise here would be the vertical distance between these 2 points. So I could draw a diagonal line down here, but I'm just going to draw a vertical line from here down to here, and that is the rise. And you can see that's a distance of 1, 2, 3 steps there. So the rise is 3, and the run would be the horizontal distance between these 2 points. So from here to here, and you can see that's just 1 space there. So the run is 1. So the slope, which is equal to the rise over the run, is 3 over 1. And if you didn't have this graph over here where you could just draw the line, sort of like a triangle over here, if you did not have that graph and you just had this, another way that you could have figured out the rise and the run is like this. So what I'm going to do here, you know what, let me just erase this. I need some space, actually. So you could have done this. In the numerator, instead of simply writing rise, I could write y2 minus y1. Don't get scared. I'm going to explain what that means in a second. And for run, instead of writing run, I could write x2 minus x1. So what do I mean by that? Let's look at this solution here again, which I called solution number 1, which was simply just coincidentally 1, 1. This is the x value of solution 1. So I can call that, I can just give it a name and call it x1. And this number over here is the y value for solution 1. So I could give that a name also and call it y1. Okay, and similarly over here, this is the x value of solution number 2. So I can call that x2. And this is the y value for solution number 2. So I can just name that y2. Okay? Okay, so what do we get when we do y2, when we subtract these two y values? So that would be 4. y2 is 4. and y1 is 1. And we could put that over x2 minus x1. So x2 is 2, and x1 is 1. So I'm subtracting x1, so minus 1. All right, and look at what I'm doing here. So 4 was the y value for the second solution. 1 was the y value for the first solution. So by subtracting them, by doing 4 minus 1, I'm really just getting the distance from here to here, which is exactly the rise that I drew on the graph. So 4 minus 1 is 3, which is the same number that I got just by counting over here. And when I say 2 minus 1, what I'm really doing is the x value for the first solution was 1, and the x value for the second solution was 2. So by subtracting these values, by doing x2 minus x1, what we're really calculating by doing this is the distance from here to here, which is the run, okay? And 2 minus 1, of course, is 1. So I get the same answers that I got by just counting on the graph. And now after all that, now we can see something interesting, which is that 3 divided by 1 is 3. That's not so interesting. But what is interesting is that this number that you get by dividing the rise by the run is exactly this number over here, which was the m value when we got it into this form y equals mx plus b. Okay? And you might be wondering, well, Mr. Freeman, is that always going to happen, or was that just a coincidence? So I know that this function has an infinite number of solutions. You just chose 2 solutions, solution 1 and solution 2, but any point along this line is a solution. So could you really pick any points on the line and subtract y2 minus y1 and x2 minus x1, do that whole thing, and that would give you this 3 over here? And not just for this equation, it could be a different equation. So I could have another equation, which is y equals negative 6x plus 47. Okay, if you did that same thing and you picked any 2 solutions that you wanted to, and then you subtracted the y values and you subtracted the x values and you divided, would that always really give you this number here, which is written next to x? And the answer is yes. And what I'm going to do for the rest of this video is I'm going to prove that that is actually the case. Okay, so I'll do it for this example, for this equation 3x minus 2. So what I'm going to do now is let's take another 2 solutions, but I'm not even going to tell you what they are. So I had solution 1 and solution 2, but there are an infinite number of solutions, right? So what if I had another solution, and let's call it, you guessed it, solution 3. And what if we had another solution, and we'll call that one solution 4. All right, now I'm not even going to tell you what the actual numbers are. Like here you knew the numbers were 1 and 1. Here you knew the numbers were 2 and 4. I'm not even going to tell you what those numbers are. I'm just going to name them x3, y3, which means the x value for solution 3 and the y value for solution 3, even though I'm not going to tell you what they are. And here I'm just going to write x4, y4, which is the x value for solution 4 and the y value for solution 4. But I'm not going to tell you what the actual numbers are. And now, what we need to do is we need to show, this is going to be our goal. If I can show this, then I proved that any 2 solutions to this equation over here would actually, if I did the rise over the run, it would give me 3. So what I'm trying to show now is that y4 minus y3 over over x4 x4 minus x3 is equal to 3. Okay? So if I can show this to you, then I'm done. Right? Now, how am I going to do this? How am I going to prove that these, if I subtract these y values here, and I subtract the x values, and then I divide them, that I get 3? How can I do that if I don't even know what those numbers are? Over here, I did it very easily, right? But I knew what these numbers are, what they were. So I could just plug them in for the y's and the x's, and then I could just do the math there. But if I don't even know what these numbers are here, then how in the world am I supposed to show that this minus this divided by this minus this is equal to 3? I have nothing to plug in. Well, there is actually a way to do it. Erase this for a second. And here's how we can do it. We're going to think logically. I don't know what these numbers are, but I do know, or I'm assuming, that this is a solution to this equation. That means if I plug this number in for x, whatever it is, and I plug this number in for y, whatever that is, then both sides would be the same. So I know that this statement, y3, whatever it is, equals 3 times x3 minus 2. I know that this must be a true statement. I know that if I take whatever x3 is, and I put it here, and then I multiply it by 3, and then I subtract 2, that should give me whatever this y3 number is. So even though I don't know the numbers, I know that if I knew them, and I put them in here, this must be a true statement, okay? What else do I know? I also know that this, or I'm assuming that this is a solution to this equation. So that means that y4 must be equal to x4 times 3, right? It's just whatever the x is times 3 minus 2. In other words, if I knew what x4 was and I put it in here, and I knew what y4 was and I put it in here, then I would see that both sides really were the same. So this must be a true statement also. Okay, and now here's the really clever part. I can say, well, if this, look, what does the equal sign mean? The equal sign means that both sides are the same, right? It means that this side, even though it looks different, is really equal to this side. It has the same value. So now I think to myself, if this is really the same thing as this, and this is really the same thing as this, then if I take this one and I subtract this one, then that should be exactly like if I were to take this one and subtract this one. Okay, again, the reasoning is if this is the same as this, and this is the same as this, then this minus this must be the same as this minus this. Okay, this minus this must be the same as this minus this. Okay, that's the reasoning there. And now we're going to fiddle around a little bit. Now I have over here, this I'm going to keep the same for a while. I think I'm running a little bit out of space, so I'm just going to, sorry, I have to erase you. And now, okay, so let me just rewrite this a little bit over here. So we have y4 minus y3 equals, this is going to stay the same, 3 times x4, which is the x value of solution 4, minus 2, and then now I have to distribute this minus sign here. So this is going to give me minus 3x3. So minus 3 times x3. And then if I distribute this again, this is sort of like a negative times a negative, which is going to give me a positive. So plus 2. Okay? And now look over here, I have minus 2 and then plus 2. If I do minus 2 and then plus 2, or like negative 2 plus 2, that just gives me 0. So these sort of cancel each other out. So now this really is looking like this. y4 minus y3 equals 3 times x4 minus 3 times x3. And now I can factor out a 3 here. So this expression, let me just copy this down. This doesn't change. I'm just dragging this along the whole time. But I can factor a 3 out of these two terms over here. And I can say that this expression is exactly like 3 times, in parentheses, x4 minus x3. Because if I were to just distribute here, 3 times x4 is 3x4. 3 times this minus x3 is minus 3x3. Okay, so this expression is really equivalent to this expression. And now the last thing that I'm going to do is I'm going to divide both sides. This is going to look really crazy. I'm going to divide both sides by this whole expression in parentheses, which is x4 minus x3. Okay, and then that whole thing, this whole x4 minus x3, that cancels out there. And what am I left with? I'm finally left with this. y4 minus y3 divided by x4 minus x3 is equal to 3. Okay? Which is exactly what I was looking for. This is what I wanted to prove, and I just proved it. Okay? So what does that mean? Again, to recap, because I know you go through all these steps, it's hard to remember why we were even doing that in the first place. What we just showed is that for any two solutions on this line over here, even if we don't know what the solutions are, we know that the rise, which we get by subtracting the y values, divided by the run, which we get by subtracting the x values, would be equal to 3. For any solutions, it doesn't matter what the particular numbers are, as long as they are a solution to this equation and they're along this line here, then we know that the rise over the run for those two solutions, wherever they are, if we were to divide the rise by the run, then we would get 3, which is exactly what we have in this x term over here. It's right, it's this number which is right in front of the x, okay? And that's for this equation. In general, if we did that same thing, then if I just took the general case of y equals mx plus b, I would just do the whole thing over again, but instead of having a 3 here, I would just have m. So whatever the m was, that's what you get when you subtract the y values and subtract the x values and then divide those two. Okay? So if that was a little bit difficult to understand, don't stress out about it. But I did want to show that to you guys, just in case you are interested. I'm not really going to test you on that. But anyway, that's that, and have a great day.